Hi there, this is Debbie, and today we're going to do an experiment to try to understand something called persistence of vision. Let's say that. Persistence of vision. Now, if you persist in something, you keep going and keep going. So there's something about your vision that keeps going, and we're going to try to figure out what that is. But before we do our experiment to try to figure that out, we're going to review our scientific method. We always look at our scientific method because good scientists use the scientific method. We're going to sing our scientific method song. The scientific method is purpose, hypothesis, materials, procedures, bing, results, conclusion. The scientific method is purpose, hypothesis, materials, procedures, bing, results, conclusion. So we already said it's going to be to try to understand something called persistence of vision. To do that, we're going to be doing an experiment, and I'll explain it to you, and then we'll choose what our hypothesis is. I've got two little faces drawn on two sheets of paper. One, the little guy has his eyes wide open. One, he is blinking. So I'm going to move this piece of paper. So you see one, then you see the other. Then you see one, then you see the other. But we're going to do it really fast. And what do we think the guy's going to do? Do we think it's going to look like he's blinking, or does it look like we're just going to see his eyes open and then one closed and not fast enough to make it look like he's blinking? So Johnny, and what do you think? And Susie, what do you think? Okay, that is your hypothesis. So let's remember it, and we'll see if you were right at the end. The materials we're going to need for our experiment are pretty basic. We're going to need some tape, something to write with, some paper, and a pencil. And we've done some of the procedure for you already. We've already cut out our paper and taped it down and drew our faces. So the part of the procedure we're going to talk about right now is that we're going to place our hands on the ends of the pencil, okay, and we're going to roll back and forth very quickly between the two lines that we drew on our paper. Here's one line, and the other is right here. It's hard to see it. And we're going to go back and forth really quickly and see what happens. So let's just take a minute and do that. Okay, I don't know if I can do it one-handed or not. Ready, go. All right, yeah. Okay, does it look like he's blinking a little bit? It will when you do it quicker. Sorry. Okay. So, the results was that it kind of looks like he is winking at us. How many of you guys picked that he was winking in your hypothesis? Okay, so you would be right. So what we learned, okay, is that when we roll back that piece of paper really quickly over and over again, our eye keeps that picture of him blinking just for a little bit longer, like 1/16 of a second. It holds that image into our brain. And it keeps that image that we see for just a little bit of time. That's the persistence. And then when you move objects really fast, it makes it look like they're moving because the things that we see are overlapping. Okay, so the conclusion is that when our eye uses something called persistence of vision, and it will keep seeing an for just a little bit of time, like 1/16 of a second, even after that object moves. Okay, so let's write our conclusion down on our piece of paper, or if we're really little, we don't have to write it. We'll just say conclusion, and let's just sing our scientific method song again. The scientific method is purpose, hypothesis, materials, procedures, bing, results, conclusion. Okay, so we have a little bit of time left. So I'm going to talk to you just about persistence of vision. And here's some examples of something that you might see that also use persistence of vision. This is something I brought in, and it's just a picture of a bird cage on one side of a pencil. And if you turn it over, there's a picture of a bird on the other side. And if you would spin this really quickly in your hands, which I can't do two-handed, but would make it, persistence of vision would make it look like the bird is inside the cage if you do it really, really fast with your hands. Some other things that use persistence of vision, okay, are things like this. And these are fun toys because little kids don't realize that the choo-choo train can go away once they press it down and it goes really fast. But persistence of vision makes it look like blurs of color. You don't see all the details. There's persistence of vision. Same with things like this little top. On this top, there's some little buttons, some little lights that light up. Okay. So when you let the top go, okay. Well, this lights up, and when you spin it, then it makes noise. It's so cool. I have to show you. Hang on. Anyway, you could bring in a top and show. Have you guys ever seen like those little flip books, or really like movie pictures, or a whole bunch of pictures, thousands of pictures, and they just show them really fast, and it looks like the people are moving in the movie picture. So today you're all going to get to take home one of these little tops. Okay, and when you spin it, you won't see the stars on the top because your persistence of vision will make all of those stars just turn into pretty, like a pretty color, maybe purple, with red and blue spinning together. So what is that called? Persistence of vision. And that is our experiment for today. And tutors, that took about 8 minutes. So of course you have 30 minutes to do this. So my idea is that if I was doing this, I would talk about the scientific method. I would sing the song at the beginning of each time. And if the kids are older, I would make them recite it and say like what each step is for, and then move to the experiment. And I don't think it's required that you write down this stuff all the time, especially for the little guys. If you just kind of go over it and they learn, they think about what their hypothesis is going to be, and then they figure out if they were right or not, I think that that's okay. I don't think they have to fill out those forms every time, but somebody else will have another idea. That's kind of up to you guys. But after you talk about the scientific method, and then you do the experiment, and you talk about how the experiment relates back to the scientific method, then it is a time for you to spend some time explaining the concept. So feel free to do that. I don't know if I realized we could do that in the past, but you can bring in some examples of things that explain the concept and take a little bit of some of that 30 minutes to actually talk about the concepts or talk more about the scientific method. Okay, girls, that's all I have for you. Take care. Bye.